So here is our circuit for part 3, all wired up. So starting on this left side over here, we are powering our switch with positive 5 volts. Then this is going to be our switch. This leg that is plugged into the power supply is our C. This next leg is going to be our NO. And this third leg is going to be our NC, and we just know this because of the circuit diagram. We also wired in our resistors according to the circuit diagram provided. Then we took those and we wired them back to our other parts with our 4011 chip. And it's not super well pictured, but that 4011 chip was our flip-flop data latch. Then, in order to get our outputs displayed on the oscilloscope, we had to get clips and plug our outputs from the breadboard actually into the channels of the oscilloscope, and not pictured in here was the grounded ends of the clips. So here is all of that together, showing our functioning circuit. Now moving on to the oscilloscope, we can see what happens when we actually click the switch. So each time it's pressed in, the shape here changes. So just focusing in on a specific moment here, we can see that when the switch is pressed, it does create a pretty substantial amount of chatter. We can see that because there are little bumps all over the lines, like it's not completely linear anymore. Even though the shape looks like it, there's still bumps throughout. So channel 1, or this yellow line on the top, is our Q output, and as you can see, when the switch is clicked, it drops down substantially, and when it's released, it goes back up. And then our Q bar output is this blue line, or channel 2 on the bottom, and it does the inverse of that, which makes sense, since a bar is just the inverse of another value. So essentially, this is doing exactly what we think it will be doing in terms of how the positions are actually switching and how they're inverses of one another. This also makes sense for it to be called a debounce switch, because that literally just means that it's removing any unwanted input noise from the switches, which is exactly what we can see here happening on our oscilloscope. So if we look at this awfully blurry image now, we can see that this circuit is going to malfunction from time to time, just depending on when you press the switch, because timing violations are sensitive within this circuit, so that will cause some slight issues from time to time.